Quarter 3 review, quadrilaterals. So here are some of the formulas and factual information we need to solve these problems. Sum of an interior angle, S is referring to sum, N is referring to the number of sides of the polygon. Keep in mind that the sum of the exterior angles of all polygons always add up to 360. So finding the sum of the interior angles of a 15gon, we're using the formula S equals n minus 2 times 180 degrees. Well, once again, n is referring to the number of sides, 15. So we're going to minus 2, so we get ourselves 13, times it by 180 degrees. 13 times 180 is 2,340 degrees. So if we added up all the degrees inside the 15-sided figure, it'd be 2,340. Part B, what is the measure of each interior angle of a regular pentagon? Pentagon is five-sided. Regular means that all the sides are the same length, which means all the angles are the same degree. So we'll be using the formula n minus 2 times 180 divided by the number of sides, which is 5. So we're going to have 5 minus 2 times 180 divided by 5. And then we're going to get 3 times 180 divided by 5. And so 3 times 180 is 540 divided by 5. And so each interior angle is 108 degrees in the regular pentagon. What is the measure of each exterior angle of a regular hexagon? So hexagon is 6-sided. Regular, once again, means all the sides are the same, therefore all the angles are the same, but we care about exterior angles. Now, no matter how many sides the figure has, the exterior angles always add up to 360 degrees. Since there's 6 sides, if we divide that 360 by 6, we find out each individual exterior angle. So each exterior angle would be 60 degrees. It says solve for x and find the measure of angle B. So first we have to figure out how many degrees do these 4 angles that we have here all add up to be. Well, it's 4-sided, so we can go S equals n minus 2 times 180, where n is 4, because there's 4 sides. And so we're going to get 2 times 180, which is 360 degrees. So this is the sum of all 4 of these angles here. So if we're going to solve for x, we're going to make an equation that adds up all 4 of these angles. So I'm going to have 8x plus 7 plus 5x plus 18 plus 14x minus 11 plus 10x plus 13. And that's going to equal 360, the total degrees in that figure. Now I'm just going to go ahead and combine all the x's. So I'm going to add the 8x, the 5x, the 14x, and the 10x together. That's going to give me 37x. I'm then going to combine the 7 plus the 18 minus the 11 plus the 13. That's going to give me 27, and that's going to equal the 360. Going to continue to solve this equation, minus the 27 to both sides. So 360 minus 27 is 333. And divide both sides by 37. And I get x being 9. Now that I know x is 9, I can find out the angle B. So angle B is 8x plus 7, and I know x is 9. So 8 times 9 is 72, plus 7 is 79 degrees. It's the measure of angle B. This one asks us to solve for x. Now, they're showing us angles that are exterior angles. They are the angles outside of our figure, which means these angles must add up to 360 degrees. All exterior angles always add up to 360 degrees. So once again, we're going to take all these and add them up to 360. So you're going to have 7x plus 4 plus 5x plus 4 plus 4x plus 9 plus 9x minus 6 plus 4x plus 1 equals 360. And I'm just going to go ahead and I'm going to combine all the x's together. So 7 plus 5 plus 4 plus 9 plus 4. That's going to give me 29x. I'm then going to combine all the constants. So I'm going to combine the 4, the 4, the 9, the -6, and the 1. 4 plus 9 minus 6 plus 1. I get 12. That equals 360. Then I go ahead and I solve. I'm going to minus the 12 over. So 360 minus 12 is going to give me 348. Bring down the 29x, divide both sides by 29, and we get 12. So properties of quadrilaterals. You've had many papers on this stuff throughout third quarter. You may still have them, you may not, but here they are if you need to refer to it during your practice problems on today's assignment. All right, so a lot of these I'm just going to kind of go over the concept by using these types of problems to let us know, figure out what these values are. So they let us know that PQ is 24, and they let us know that PS is 19. So by knowing that this is a quadrilateral, it's a four-sided figure, that the sides opposite of them are congruent. So this is a 24 and this is a 19. So I can already answer that QR is 19 and RS is 24. Continuing on with some of the information they have given us, that PR, so this length right here, a total length of 42. So if PR's entire length is 42, and it wants to know what the length of PT is, keep in mind that this length QS and PR intersect each other at the midpoint. So they are actually meeting right here in the middle. These two cut each other in half. So this length is going to be half of 42. So this is going to be 21, and so therefore TR is also 21. When the two diagonals intersect, they cut each other in half. And that's why PT is 21. So now we need to figure out what SQ is. So we can do this by looking back at our information that TQ is 10. And once again, where they intersect, cut them in half. So ST also has to be 10. Therefore, 10 plus 10 is 20, which is what SQ is. Now that I have all that information for the sides, it's now starting to ask me about angles. So I'm going to erase this, because now I care about all the angle information they're providing in the statement above. So the first thing they tell me is that PQR, this entire angle from here to here, is 106 degrees. They also let me know that angle QSR, this one right here, is 49 degrees. And the last thing they let me know is PRS is 35 degrees. So by knowing that bit of information, I can find a lot of the other angles And I'm going to do that before I start trying to answer these specific questions. So one of the properties of a quadrilateral says the two opposite angles of each other are the same. So that means this angle here is also 106 degrees. So if I know part of it's 49, all I got to do is subtract away the 49 from the 106, and I learn that this right here is 57 degrees. Well, you'll notice that this is a triangle, which means I can go ahead and find this angle right here where T is located by subtracting the ones I know away from 180. So 180 minus the 49 minus the 35 makes this angle 96 degrees, which means by vertical angles, this is also 96 degrees. So from here, we can find out a linear pair. So linear pair are two angles next to each other on a straight line. So if I know this right here is 96, I can find out the one right there. So 180 minus 96 is 84. So I now know that this is 84. And once again, by vertical angles, this is also 84. So from there, I can figure out this angle right here. So I have 57 plus 84. If I subtract that from 180, I learn that this is 39. And once I know that, this right here has to be 35 by alternate interior angles. This is 35, this is 35, and therefore this has to be 57, and this has to be 49. And this is one of the properties that, since this is a quadrilateral, the alternate interior angles, the 49, 49, are going to be the same, and here we see the 57s, those positions are going to be the same. That's also true for right here, you see the 35 degrees in green and the 35 degrees in red. Those are opposite interior angles, and they should always be the same. Therefore, 39 should also be here. Now that I found all the angles in the picture, I can answer these questions on the side. QRS is talking about this big angle here, so I'm going to add 39 and 35 together, and I'm going to get 74 degrees. And then PQS, so they're talking about this angle here, that's 49. And then we're looking at RPS, so we're talking about this one, 39. And then we're talking about PSQ, so we're talking about the 57. And that's using our properties from the last slide to figure all these out. So once again, this is going to be a quadrilateral, and it says NS is 2x plus 7, and SQ is 5x minus 23. Now remember, in a quadrilateral, then the two diagonals cross in the middle, the two you've cut that segment in half. And therefore, each of those segments are actually equal to each other. So I can go 2x plus 7 equals 5x minus 23. And I can just solve for x by minusing 2x to both sides. So I have 3x minus 23. I can go ahead and add the 23 over. So I'm going to get 30 equals 3x divided by 3. So x is 10. And now I can find NQ, since I can figure out what NS is. So NS, I can plug the 10 in for the x now. So that is going to give us 27. And so I can plug into an SQ as well. So 5 times 10 minus 23 is also going to give me 27, since they should be the same. And so 27 plus 27 is 54, and that is the length of NQ. All right, so here we have ourselves a rectangle. So with a rectangle, we are going to use our properties of a rectangle to find out all the angles that they're looking for. So one thing they did provide to us is the 59 degrees here. And with that one angle, we can find everything else. So first off, remember that a rectangle has a 90-degree angle in each corner. So if I know this is 59 degrees, then I know angle 11 is going to be 31 degrees, because all I did was go 90 minus 59, which is 31 degrees. So now I can continue with the process. Once again, with a rectangle, alternate interior angles. So angle 3 is also 59 degrees, alternate interior angles, and therefore angle 4 is 31 degrees. And since we have ourselves a rectangle, one of the properties of rectangle is these 4 angles are congruent, which means in reality that the little triangle that you see I'm marking in purple is actually an isosceles triangle, which means that if this top angle here is 59 degrees, so is angle 6, because in an isosceles triangle, the two base angles must be the same. Therefore, we now know angle 1 must also be 59 degrees based on alternate interior angles. And that means we also know that this right here is an isosceles triangle as well, because this length and this length are the same. So down here, this is 31 degrees, and by alternate interior angles, angle 2 is also 31 degrees. So we've actually found quite a lot of angles so far, so let's start filling them in over here. So angle 1 is 59 degrees, angle 2 is 31 degrees, angle 3 is 59 degrees, angle 4 is 31 degrees, angle 5, 31 degrees, angle 6 is 59 degrees, angle 7, angle 8, and angle 9 and 10 we'll have to find, but we know 31 degrees is for angle 11. So now we use the property of a triangle. If you know that a triangle has 180 degrees in it, and we know these two are 31, we can find angle 7 by saying 180 minus 31 minus 31. And we are going to get 118 degrees. So we now know angle 7 is 118 degrees, and by vertical angles, angle 10 is also 118 degrees. So angle 7 and angle 10 are both 118 degrees. Now, you can do that same idea right here for this green triangle. Once again, 180 degrees is in a triangle. We know the two corner angles are 59, so if we subtract them away, 180 minus 59 is 62 degrees. So we know angle 9 is 62 degrees. And by vertical angles, angle 8 must also be 62 degrees. Problem 7, still dealing with a rectangle. They let us know that JM is x plus 17, and that MK is 5x minus 23. Now once again, in a rectangle, all 4 pieces of the diagonals are equal to each other. So I can go x plus 17 equals 5x minus 23. All I have to do is solve for x. I'm going to minus the x over here to get me 4x. I'm going to go ahead and add the 23 over to get x by itself. So 40 equals 4x, divide both sides by 4, x is 10. Now that I know x is 10, I can go ahead and find JL. So I'm going to go ahead and I'm going to plug it into this one, which is JM. So 10 plus 17, that's going to give me 27. Now remember, if this is 27 here, this is also 27. Because once again, all four pieces of the diagonal are going to be congruent. So therefore, if I'm looking for J to L, I'm going to add the two 27s together. So 27 plus 27 is 54, and that is JL. So this figure is a rhombus. And they let us know that ZY is 34. Now in a rhombus, all four sides are congruent. So this is 34, this is 34, and this is 34. They also let us know that this length WY is 38. Well, when the diagonals cross each other, they cut the diagonals in half, which means half of 38 is 19, so each of these is 19. Now, if we want to find these two right here that I'm marking, we need to use Pythagorean theorem. And we can use Pythagorean theorem because right here, there's a triangle. And in a rhombus, all the center angles are all 90 degrees. So I can use a squared plus b squared equals c squared to find that missing side. The 34 is our c because it's opposite of the 90 degrees. I'll make b the 19, and I'll make a the one I'm looking for. So 19 squared is 361, 34 squared is 1056. I can subtract the 361 over, and I get 795. Want to get what a is? I'm going to square root it to get 28.2. So this right here is 28.2, and this is 28.2. So therefore, if I start filling in the information that I know, this is 34, Vy is 19, V is 28.2, Zx is taking the 28.2 plus the 28.2. We're going to get 56.4. And that's how we find all the segments for our rhombus. Now they're talking about the angles. So to find all of our angles, I'm going to erase the picture so we can kind of see it a little bit more clearly. So now I'm going to go ahead and label the information they've given us about angles. So they tell us ZXY is 34 degrees. Now the properties of a rhombus says that this diagonal ZX cuts this angle right here in half. It bisects it. So this is 34 degrees. Since a rhombus is a special type of parallelogram, the angles opposite of each other are congruent. So these are also 34 degrees. Now we know that these are all 90 degrees as stated earlier. So if we want to find out what these last four angles are, keep in mind that a triangle has 180 degrees. And if I'm talking about this triangle right up here, I know one angle is 90 and I know one angle is 34. When I subtract that away from 180, I get 56 degrees. So all these are 56 degrees. So now I can go ahead and fill in the information on the side here. WXZ is 34 degrees. WVZ is 90 degrees. ZYW is 56 degrees. And XYW is 56 degrees. Okay, here we have a square. So they let us know that the side AD is 11, and in a square, all four sides are congruent. And in a square, since all four sides are congruent, we can find the diagonal by making ourselves a nice right triangle. So we have a squared plus b squared equals c squared. And in this time, we are actually trying to find the c, the hypotenuse, which is going to be our diagonal. So we have 11 squared plus 11 squared equals c squared. So that's going to be 121 plus 121. So 121 plus 121 is 242 square root. So square root of 242 is 15.6 if we round to the nearest tenth. All right, so we can probably answer some of our questions now. So BC is 11. AC we found was 15.6. BD is also 15.6 because in a square the diagonals are congruent, just like in a rectangle. EC is going to be half of the 15.6 because just like a rectangle, all four pieces of the diagonals inside the square are congruent. So we can just take the 15.6 and divide it by 2, and we're going to get 7.8. So we know this is 7.8, 7.8, 7.8, and 7.8. So EC is 7.8. Now they want to talk about the angles. So I'm going to erase everything we have here, and we're going to talk angles. So in a square, in many ways it's like a rectangle where all four corner angles are 90 degrees. Now, since they're all 90 degrees and the diagonals go through them, the diagonals actually cut them in half. So each one is 45 degrees, all these little ones, which of course 45 plus 45 adds up to 90. Those big angles get bisected. And these angles right here in the center are all 90 degrees, just like a rhombus. So now we have all the angles labeled here, so we can actually answer the information on the side. Angle DAB is 90 degrees, because it's talking about this entire angle here, so 45 plus 45. Angle AEB is talking about this 90 degree angle right here. Angle CBD is 45 degrees. And angle BAC is talking about this 45 degrees. And we have found all of our missing stuff. So when you're doing your worksheet, please make sure you skim back in this video to where the properties of all the parallelograms are to help you solve the problems.